Okay, so section 7. The first thing we're going to talk about is simplifying radicals with negative radicands, recognizing subsets of complex numbers, and adding and subtracting complex numbers. And then at the tail end, we'll add on our one objective from 8.2. So let's go ahead and take a look at what we are calling and what we know to be the imaginary unit I. It's defined as the negative underneath the radical, which means if we were to find I squared, that would just be equal to -1, because the square root of -1 squared, that would be -1 to the 1/2 times 2, or raised to the second power, which will cancel and leave us with -1. There's also I cubed and I to the 4th, and they do keep going. They are cyclic, so they every 4 rounds is the same. So I, -1, negative I, and then 1. Okay, so and they rotate like that. We can use this definition to define any square root of a negative real number. For any positive real number b, the square root of -b is equal to I square root of b, unless b, of course, is a perfect square, then it'll just be with the I. And I'll show you what I mean by that. So a is a perfect example. The square root of -49. So square root of -1 times the square root of 49. That will give us, well, let's put them opposites there. Let's do square root of 49 first, -1. So that's going to be plus or minus 7i. Okay, plus or minus, take it or leave it. You can continue with it or not. I'm not going to take off points. Same thing here. We have a negative square root of 121 times -1. So then we have negative, I'm not going to worry about the plus or minus, 11i. Okay. Okay. So for C, the square root of 3 cannot be simplified, so it's just going to be plus or minus I square root of 3. Now, 32 can be simplified a little bit, so that's going to become 4 squared times 2. So 4 square root of 2. We're actually going to leave a little bit of space here, and we're going to do plus or minus 4i square root of 2. That is the complete true answer there. Right? Okay, let's keep going. Now we're going to multiply. So we would have here, instead of multiplying inside like you would want to do, what you're going to do first is you're going to change them into i's, although let me just double check something here. Oh, you can do it either way. So you can either you can change it to the i's and do 2i times 4i, and you get 8i squared. which is equal to -8, or that's like approach 1. So method 1. A second method would be to say, well, -4 times -16 gives me a +64. Oh yeah, we can't do it that way because then that gets rid of the I. Yeah, we can't do that. We cannot do that. Okay, you have to do it this way. All right, otherwise you get rid of the squared term or the I term, and that is not okay. So the answer here is -8. All right, so here we would have 5i times 11i gives me 55i squared, which is negative. Oh yeah, apologies. These do not come out of the square root, so I square root of 5 times I square root of 11 equals I squared square root of 55, because 5 times 11. So that, and remember I squared, recall from what we just learned on the other slide, I squared is equal to -1, so negative square root of 55. C is I square root of 3 times I square root of 2 squared times 3. So that's I square root of 3 times I 2i square root of 3. Which then becomes 2i squared times the square root of 3 squared. So that will become 2 times 3 times I squared, which is 6 times -1, which is -6. So then we have the square root of 13 times I square root of 2, which is just I square root of 26. Okay, and now we need to do some division. All right, so what we can do is we can pull our i's out. They are going to cancel. And then 72 divided by 8 is 9. So we end up with the square root of 9, which is just ±3. We're going to bring the I out. Square root of 48 divided by square root of 3. Well, that's I square root of 16. So that'll give you ±4i. All right, complex numbers. If A and B are real numbers, and then any number of the form A being the real part and BI being the imaginary part is a complex number. In the complex number A plus BI, the number A is the real part and the b is the imaginary part. Okay, so we're going to work with some of these. I threw this in because we're supposed to talk about the different places that complex numbers are. So we have real numbers on the left, and you can see they start with natural numbers, whole numbers, integers, rational numbers, irrational numbers, and then real numbers where the b is equal to 0. So there's no imaginary part. Complex numbers, b is anything but 0. Here are some examples. And then pure imaginary numbers fall in here. All right, so we are going to add, and we have to add, interestingly here, we add the real and the real and the imaginary and the imaginary, and we never bring them together otherwise. So -3 plus 4 is our real part, plus 2i plus 7i. So we are going to get here 1 plus 9i. Then here let's just write this, rewrite this so you can see everything all together. I'm going to put the real parts together. So 5 plus -3 plus 6 plus -i plus 3i minus 4i. So in the real part, we are looking at 11 minus 3, which is 8. And then here we have minus 5i plus 3i will give us a minus 2i. Right? So we are done there. And I would recommend doing it that way. I would not try to do it any other way than that. I would do my reals and my imaginaries and leave it at that. Same thing here with the subtractions. So I would do 7. Now in this case, we have to remember that each of these changes signs. So 7 minus 3. We could have a plus or a minus, so it just depends on what happens here. Just gonna leave it as a plus for right now. And then it's gonna be 10i minus 5i. So that actually works out to be 4 plus 5i. Right here, we have to distribute again. So 5 minus 9 is the real. Leave it as a plus again. We're going to have minus 2i plus 7i because it's minus is a plus. So that's going to give us -4 plus 5i. Interesting, they made that so similar back to back. And then here again, we have to distribute. So we have -1 plus 1. And then again, I'll leave this as a plus. And it's going to be 12i minus is a plus I. So that gives us a 0 in the real and a plus 13i in the imaginary. We can actually just write it as 13i. We do not need the 0 in the front. Okay. That is where 7.7 ends. Section 8.2 is literally just called the quadratic formula. This is the quadratic formula. You will want to have it memorized. Once you work with it long enough, it comes right to you. To be honest, you won't even need to memorize it that long. But here's how we work it. We normally have a situation of ax plus by plus c equals 0, or sometimes it's equal to c and you have to subtract it over. But in our case, we have a equal to 2, b equal to 3, and c equal to -20. So we're going to plug this into our quadratic formula, and we will get -3 plus or minus, so see the b is opposite sign, square root of b squared, which is 3 squared, minus 4 times a times c all over 2a. So then we just go through and clean stuff up and then go from there. So 3 squared is 9, minus, so we're going to have a plus there. So 4 times 2 times 20 will give us 160. And then 2 times 2 gives us 4. So we have -3 plus or minus the square root of 169 over 4. So that gives us x equals, stop it. -3 plus or minus the square root of 169 is 13 over 4. So you're looking at -3 plus 13 over 4. So that's going to be 10 over 4, which is 5/2. And then you'll also have -13 minus, or -3 minus 13 over 4, which is -16 over 4, which is -4. So your answers are x equal to -4, comma, 5/2. That is your solution set. Okay. And if you were to have graphed that or tried to factor it, you would have ended up getting in the same spot. So there you are with that. All right. We got a couple more of these, so let's work those out. Again, we have a here equal to 4, b is equal to -20, and c this time is equal to 25. So we have x equal to -b. So -b times 20 plus or minus square root of -20 squared minus 4 times a times c all over 2a. So that's going to give us 20 plus or minus 20 squared is 400, I'm pretty sure. Yes, 400 minus 4 times 25 minus 400. Oh, interesting. That's gonna piece out like a Club Scout. Okay, my 8 is not doing anyone's justice. 8. And then that ends up giving us x equal to 20 plus or minus 0 over 8. So our answer here works out to be 20 over 8, which we can then reduce top and bottom by 4. So divide by 4, and we end up with x equal to 5 over 2. So what that's saying there is that we have x equal to 5 over 2 really twice. But We'll go with it like that. All right, 2 more. And you guys could see there that I didn't even need to rewrite the I didn't even need to rewrite the quadratic formula because I've just been working with it for so long at this point. And I'm pretty exhausted. It's 3:14 in the morning. So if I can do it at 3:14 in the morning, after you guys work with it for a little bit, you should be okay. So here we have A equal to 3, B equal to 5, because I moved it to the other side, and C equal to 1. We're going to add it all into our quadratic. So this will be -5 plus or minus 5 squared minus 4 times A times C all over 2A. This is -5 plus or minus 25 minus 12 all over 6. X is equal to -5 plus or minus square root of 13 over 6, and we can't do anything else. So that is your answer here. You still have 2 answers because you have a plus or minus situation going on. Some students like to get the decimal equivalents there. I will give credit on the exam for the decimal equivalent, but I would not recommend it. And more than likely on your final exam, it'll look like that. And on anything, probably with Pearson, it'll look like that. You will not. So try hard. Try hard to answer in radical form papers. Not with decimals. Okay. All right, last one. We got to do some work for it, of course. So we got to FOIL first, outer, inner, and last. And then we also have to add the 18 to both sides. So we're going to end up with x squared minus x plus 13 equal to 0. So we have A equal to 1, B equal to 1, and C equal to 13. And what you'll learn eventually is that the discriminant, which is the part under the radical, it tells you certain things depending upon what it is. So if it's 0, it means one thing. If it's negative, it means one thing. If it's positive, it means another thing. So eventually you'll learn all of that. Oh, oops. I didn't finalize my answer up here correctly. I just kind of got rid of the one thing. I need to combine this here. So let me fix what B is. B will be positive 4x. So let's go ahead and plug this into our x. We have -4 plus or minus the square root of 4 squared minus 4 times A times C all over 2 times A. So -4 plus or minus 16 minus 4 times 13, 52 divided by 2. 16 minus 52 gives me a -36. So -4 plus or minus -36 over 2. So we're looking at x equal to -4 plus or minus 6i over 2. Everything gets reduced by 2, so that becomes a 3. That becomes a 2. So we're looking at x equal to -2 plus or minus 3i. And I would just leave it in that form. I wouldn't go through and get I wouldn't do like -2 plus 3i and -2 minus 3i. I would just leave it like that. But that is it. That is it for your notes for math 1033 intermediate algebra. I will be coming back shortly with your review video, but that's it for notes. So you guys did it. Congratulate yourselves and study hard for the final and for your chapters 7 and 8 exam, which is on Wednesday.